They asked me to go over 6, so I'm going over 6. So first is the x plus 1. I take the x plus 1, I plug it in. So I'd get 2 times x plus 1 minus 5. 2x plus 2 minus 5 is 2x minus 3. That takes care of that part. Then the negative on the front says change all these signs. So negative 2x plus 3. And then the very last thing at the end, add the 4. I got the 2x part. Yeah. No, sir, there's no such thing as a... Like once you get your quiz or test? Actually, so this is not on your quiz. I'm only quizzing you on 114, but this will be on your test. Oh, yeah. So if it's, but it's different depending on what you're doing. Remember, movement, you stretch, then move, but the move doesn't matter the order. So the stretch has to come first, but you could go right, left, up, down, upside down. That doesn't matter the order. On these, it's almost like order of operations. You're going to start with the parentheses, whatever you would change there, and then work your way out. So I start with parentheses, meaning I would do the x, in this case, the x plus 1 gets plugged in first. Then I would move to the left because that's still all multiplication. Then I would do the negative, and then I would add the 4. So it's almost like an order of operations. When you're graphing it, the only thing that matters is if there's a stretch, you do the stretch first. After that, the move order doesn't matter. The stretch has to happen first, but the move order doesn't matter. No, doesn't matter. All right, then 7, it was 20, 8, negative 3, and 9, 7. Negative 3. Okay, so 12 says, given the graph has the domain, blah, 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 the range, da, da, and then it says negative on the front. So remember, negative on the front is what? It's over the x-axis, so it changes the y's, which would change your range. So that's the first thing. My range, which is negative 2, 8, okay? Well, I did the other order, but it doesn't matter because remember, the order doesn't matter for that one. The other change to the y is the negative 6, which is down 6. So we moved it down 6, negative. We did the negative first. Sorry, that's what this is. I did the negative first. So I took my negative 2, negative 8, made it 2, negative 8, and then shifted it down 6 places. Negative 4, negative 14, but then you have to switch your order because negative 14 is smaller. I didn't do domain yet. This is range. I think so. And certainly if it was multiple choice, it would be that order, so you would just need to know to look for it. But if it was open, I don't know that this would be an open-ended question, but more of it is multiple choice than open-ended, yes. All right, but that's your FRQs are all open-ended. A free response question. All right, the domain comes from the inside, right? The inside is the left-right switch, and that is left 3. So I subtracted 3, negative 8, negative 1. I subtracted, that's my answer, thank you. Negative 3, negative 3, and it's negative 5, 2.
Negative 5, 2, right?
Yep.
Can you go to 10?
Yeah. So this one is just the inside right, which is left 3. Left 3 is your domain. Left 3 is minus 3. So negative 4, 0. And then 5, 10 didn't change. Oh. All right, then you had your dilations. So the first one was a stretch by 2, a flip over the y-axis, so a change on the x. So if you had that switched, obviously that was from there on the notes. And then up 3. It's probably, number 1 is probably the same issue if you have it different.
So inside is y-axis.
Inside is over the x-axis, or over the y-axis, but the y change, no. It's over the y-axis and the x changes. Yep. Number 2 was a horizontal stretch by a factor of 2 and down 1. Number 3 is a horizontal compression by a factor of 0.5 and right 4. If it's inside, it's the opposite. Yep. So the horizontal compression and stretch is the opposite. You do the reciprocal.
But like for example, for the what's it called? For the graphs, you do multiply it by
The reciprocal. The factor is the reciprocal. The reciprocal is what you multiply by. So you're multiplying by the factor.
so every single time, no matter what,
Horizontal.
it's the reciprocal.
For horizontal. Yes. So it's 1/2. Hang on. They asked me to do this. So it's 1/2. It's on the x. So I had to change the x by multiplying by 1/2. Shh. So this -3 went to -1.5. This -2 goes to -1. 0 would stay 0. 1, you guys, shh. 1 goes to 1/2 and 2 goes to 1. So this would have been my compressed. Then everything got shifted to the right 4 places. So I went 1, 2, 3, 4. I went 1, 2, 3, 4. I went 1, 2, 3, 4, and 1, 2, 3, 4. So shrink or stretch, compress, and then shift.
-3x squared plus 11.
Yep. All right, the good news is we've done the first couple of slides. Okay, this is function, model, selection, and articulation assumption. What it means is you are going to figure out if these in the beginning are supposed to be linear, quadratic, cubic. We did that part already, okay? Then we're going to learn how to use some piecewise functions, and then you're going to get some real world questions based on quadratics and cubics and that kind of stuff, okay? So in the beginning, again, we have already done this. We just use different wording. And that is to determine the appropriate function to a model situation. So if I am given data and the first difference is a constant, it's linear, right? If I do y2 minus y1 and y3 minus y2 and all that stuff on an even interval, and they are the same the first level, then that is called the first difference. And if they are constant, it's linear. If it takes to the second difference for it to be constant, then it's quadratic. And if it takes to the third, it is cubic. We will eventually get into quartic. We're going to get into exponential. We're going to get, but that is later, okay? Not in this chapter even. So it literally will just give you something like this. It says determine the appropriate model for the data and explain why it models the data. So the first thing is you have to look at your x values, and they have to be in even increments. So if I look at A, does the x value change in even increments? Yes. So I can literally ignore the x value and just go to the y's. So I could do 5 minus 15. It's a bad color. 5 minus 15, -1 minus 5, -3 minus a -1, -1 minus a -3, and 5 minus a -1. So 5 minus 15 is -10, -1 minus 5. So already I know this is not linear. Then -3 minus a -1 is -2, -1 plus 3, +2, and 5 plus 1, 6. So I've ruled out linear because if they were already the same, then it would be linear. Now I go to the next one. So -6 minus a -10, +4. -2 minus a -6, +4. 2 minus a -2, 4 again. 6 minus 2, 4. So that took to the second difference, which means this is quadratic. And when it says explain why it models the data, we would say the second difference is constant, or the second difference is 4. So you have to say first difference, second difference, third difference, like that. Yeah, sure.
Would it ever ask a question now where it just says find the degree, or would it ask it like this?
It's going to ask it like this now. Yep. Even on the practice test, though, for the AP, it will ask degree sometimes. So, I mean, they're both, or it will say what type of model, and that's where it's looking for linear quadratic. So you just got to look at what it's asking. Degree or determine the model. A lot of times that part is multiple choice, too. All right, so go to B. Are these going in even increments? Yes, right? They're going down by 2. So I don't even need to put it over 2 as long as I continue to keep it constant. So negative 15 minus a negative 18. Negative 12 minus a negative 15. Negative 9 minus a negative 12. Negative 6 minus negative 9. Negative 3 minus negative 6. They are all 3. Good. Which means this is linear. First difference is constant and 3. Yep.
Would it ever ask us? Oh, yeah, wait. So we have to put and 3. Wait, we said what if we're subtracting from right to left?
You'd have to also switch to your other sign. So if it was asking for the specific rate of change, so that the rate of change here would be 3 over 2, because it'd be negative 6 minus a negative 8. So the rate of, that's different. If it asks for average rate of change, you'd have to put it over the 2.
But I'm saying because it's saying that it's of 3.
Yeah.
That's the change. If you did it right to left.
I think if it's, you're just classifying it, it won't matter. But if it asks for rate of change, obviously that sign is important.
So I just have to put
This part would be fine for the answer depending on, yeah, like your sign wouldn't change for that one. It doesn't matter, the sign. But when it's asking for the rate of change, it does matter.
So if I'm going right to left, I just always put the sign at the end. And that's the.
Sure.
Okay.
Yeah.
And that's cool.
Yeah.
Wait, why can't you just go from left to right? Because that's like plus 3.
So that's what he's basically saying. That's the same thing. Yeah, yeah. It wouldn't matter unless they ask for specifically the rate of change. Now your sign matters.
Because you're going backwards.
Does that make sense?
Yeah.
Yeah, okay.
Do you have to write out the subtraction in your timer? Could you just like look for the change?
You can look for the change. On linear, you probably be able to see it. Yeah, yeah. If it's not linear, no. But yeah. Okay, go to C. What's different with this one? These intervals are not the same. This is going up by 2. This is going up by 1. 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 So if it starts with 2, I got to keep it consistent that way. But you can actually skip things to keep it consistent. So if I use my interval of 2 for that first one, and then I go from negative 1 to positive 1, that's an interval of 2. I could literally skip the one in between. And then if I want to go from 1 to 3, that is also 2. So I could skip that one. I have to go on the interval I started with. So if it starts with 2, I got to find a way to make it 2, okay? But there are times in which you can skip like that. Dane.
So you can't just start from negative 1.
Correct. You can't ignore the beginning or the end, basically. And if you did, like, you'd have to find the average rate of change in order to do that. But you won't, it has to be the same interval in order to use this first difference, second difference test. So now I'm going to use negative 7 minus a negative 11. I'm going to skip this one. I'm going to do negative 3 minus a negative 7. I'm going to skip this one, 1 minus negative 3. So this becomes plus and that's 4. This becomes plus and that's 4. This becomes plus and that's 4. Which means this is linear first difference. So be careful and make sure you're checking your intervals. So like questions like this might say, is it linear, quadratic, cubic? At this point, it would only give you 3 options or none of these. None of those could be an answer, okay? Eventually, we will pull in lots of other models. But for this chapter and this section, we're going to stick the most would be cubic. All right, so now we're going to talk about restricted domain and range, and this is based on like real world application. So if I had a real world question, so this one's about a bottle rocket, okay? You have to think about, would there be restricted domain and range on this based on that real world scenario? So if I have a bottle rocket set up on a picnic table, when the firework detonates, it will shoot straight up and come back down again. So this is going to have what kind of shape? It's going to go up and come back down again, right? Look at my function. This is going to be a quadratic shape, right? If it's set up on a picnic table, that could mean it's already starting up here, okay? And then going up and coming back down again because it's not on the ground. It says the height of the rocket is modeled by that function where T stands for time in seconds and H is the height of the rocket in feet. A says find H of 1, and what does it mean in this context? So how would I find H of 1? Plug in 1. So negative 15, 1 squared plus 62 times 1 plus 2. I get negative 15 plus 62 plus 2. And you get 49. What does it mean in this context? Means now give these their measurements, right? What does that mean? What was my T and what is my H? T is seconds and H is height. So describe that point to me using those measurements. Good. So after 1 second or at 1 second, whatever it is, after 1 second, the rocket is 49 feet in the air, is 49 feet above the ground. The height of the rocket is 49 feet. All of that stuff would be fine. Then B says, what's the restricted domain? So think about domain here. Domain is what? X or Y? X. So what kind of constraints could I put on my X? Where it starts and where it ends. Okay? So what's the very first X? 0. Even though this is a parabola, and technically it would work backwards here, we don't count that part, right? It doesn't go back in time. So our first X is 0. So that's the one part of our, and that's our time. And then the last X on this would be what? I think I heard you. What? When it hits the ground, what do we call that spot? The x-intercept or? 0. So how do we find that? Plug in 0 means the y-intercept, right? Plugging in 0 is this part here. How would I get that? For y. Plug in 0 for y. Yes? Or use my calculator. You're going to have a calculator. This is not going to be factorable. You'll have a calculator and you're going to find that 0. So I'm literally going to plug in negative 15t, or which is my x, squared, plus 62x plus 2, and I'm going to hit graph.
What was the first thing you were showing us?
Which part?
Where you said you just press the
If you hit trace, you know how we used to do second trace, go to value? If you just hit trace and then hit the number, it will take you there. You don't have to go to value. Questions on this one? All right, now we go piecewise. So we've talked about piecewise functions. You evaluated piecewise functions, but now we've got some real world context. This says the graph of F below shows the price of a concert ticket during the first 10 hours that the tickets go on sale. The cost of a ticket starts at $80. This is obviously a cheap concert these days. Cost of the ticket starts at $80 for the first 2 hours and then increases each hour. So it is not exponential, right, or increasing, because there's a set price for the hour. That's the thought process here. And that creates a piecewise function. So for the first hour, it's $80. And it stays that way, or the first 2 hours, according to this. And then from hour 2 to 3, it's now $90. And then it goes to 100, and then it goes to 110, and so on and so forth as you go. Okay? So that's what causes a piecewise function. So it says, what's the domain in this context? Domain are my x values, right? So what's the smallest x value? 0. Is it a solid dot or an open dot? Solid, so it includes it. So I would either do this or I would do this. What's the biggest? 10, and this time open dot, which means it does not get an or equal to, and it gets a parentheses.
We are so lucky that it overlaps.
Well,
That would take forever.
wait, because we're about to do the range. What's the range on this context? It stops every 10 increments, so I can't include any of the points in between. So when I'm doing this, you're literally starting at 80, 90, 100, 110, 120, 130. You guys are such whiners. What's the all the way to the top here is 160, 140, 150, 160. You cannot list the in-betweens because there's breaks there.
So you need to put the union.
No, you literally comma, 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 comma. Because there's no range. That's it. That your brace says this is my set. No.
I thought you had to do that.
No, I'm gonna watch for your homework specifically. Lazy.
Wait, is that a parentheses or a bracket?
It's a brace, so it's like the squiggly thing because it's not an interval. It's a list. So it has to be that. What?
Yeah, that's squiggly.
Yeah, it can't be a parentheses. Again, I don't know how particular they will be, but no, it's the set. So a set, that's how you put set notation.
There's a set notation.
Yeah. It's like what's included. All right, C says find f of 7.5, and what does it mean in this context?
140.
So 7.5 is here. I'm going up, right? This is 140. What does that mean in this context?
The price at 7 hours and 30 minutes.
5 hours
Is
30.
The price of the ticket at 7 hours and a half is $140.
$140. So something along those ways. 7 hours and 30 minutes, 7.5 hours, 7.5 hours, whatever. It is 140. So you have to be specific. $140.
Exactly, not 140.
Uh-huh.
140 what? Pigs?
140 pigs would cost more than $140. I would not. It's a lot of work too. Questions? All right, last section or last little bit is real world problems involving area and volume. So if you think about this, right, what kind of functions would you have for area and what kind of functions would you have for volume, right? So think about your area and your volume formulas, okay? If I'm talking about like a square, what's the area? It would be quadratic. It would be like side squared. Yes, you're multiplying two things together. That would produce a quadratic. If you're talking about volume, it's cubed because it's three things, okay? So normally area problems are going to produce a quadratic function and volume problems are going to produce cubic functions. And again, some real world stuff. The volume of a right cylinder has a height of h. That is 4 times the length of its diameter d. Find the function v of r that represents the volume of the cylinder in terms of the radius, recalling that the volume of a cylinder is pi r squared h. All right, so it says that the height is 4 times the length of the diameter. So my height is going to be 4 times the diameter. But I also need my radius, right? What is diameter? 2r. So really, height is 4 times 2r, or the height is 8r. With me so far? Okay. Then, obviously, I need to find the volume. So the volume would equal pi, r is r, and my height is 8r. So the volume is pi, and then 8 times r would be times 8 times r cubed, or 8 pi r cubed is how I would write it. No, order doesn't matter as long as you're careful and make sure that you don't do anything weird, okay? Then it says use the formula found. What's the reasonable domain and range for the problem if the diameter can never be larger than 12? So first, what's going to be a restriction on the domain if this is a real world volume? Can it be 0? No, it has to be bigger than 0 this time, right? Which means parentheses or the less than without the less than or equal to. So my domain is my radius, because that's what I'm plugging in. And it can't be 0. I don't know what it has to max out at yet, okay? And my range is what I'm getting out of this. My range would also have to be greater than, and my range is my volume this time. And then I have to find the max values. So if it says the diameter can never be larger than 12, diameter has to be less than or equal to 12, because it can be 12. It just can't be larger than it. What does that mean, my radius? Good. So now I have a max on the radius. And then you'll plug it in to find the max on your volume. So the 6 goes in to 8 pi 6 cubed 8 pi 216. And 216 times 8.
Is this a calc or non-calc?
I think it's non-calc.
So we're gonna have.
Is it?
All that time doing 6 cubed and then 6 cubed times
260, 17,
Huh?
What do you think the diameter?
The diameter, like the max? It says it can never be larger than 12. That part? It tells you that the height is 4 times the length of the diameter. And diameter is 2 times the radius. Like, that's just what diameter is. So I would say without a calculator, it would be 1728 pi. With a calculator, it would tell you to actually round that to well, it won't tell you what to round to. You have to know to go 3 decimal places. So 1728 pi, 5,428.672.
So on the quiz, are we gonna have to multiply out?
No, never. You're using pi. Yep.
Always pi. Okay.
Always pi. Yep. Use actual pi.
So if it gave us a restriction on how, and that has to be bigger, then we would still put it for
Yeah. Questions? All right. When you do